afternoon, my beautiful people. I go by the name Shotade Olusegun. In this particular live session, I want to review the Veritasium video on Markov chain. So it actually, independence versus dependence. So independence, which is, synonymous to free will. Then dependence, that, the parallel relationship must actually be dependent on the later event. So the parallel event must be be dependent on later event. I think that is similar to cause and effect. Like there must be a cause before we can actually have effect. Now this particular video interests me because it deals with it, it tackles one major issue. It's all about the issue which is about free will, dependence versus independence. So we're going to watch this video, and then after it I will give my own opinion on it. So please, with no further ado, let's...
Times do you need to shuffle a deck of cards to make them truly random? How much uranium does it take to build a nuclear bomb? How can you predict the next word in a sentence? And how does Google know which page you're actually searching for? Well, the reason we know the answer to all of these questions is because of a strange math feud in Russia that took place over 100 years ago. In 1905, socialist groups all across Russia rose up against the Tsar, the ruler of the form, or failing that he stepped down from power entirely.
This divided the nation into two. So on one side, you got the Tsarists, right? They wanted to defend the status quo and keep the Tsar in power. But then on the other side, you had the socialists who wanted this complete political reform. And this division was so bad that it crept into every part of society, to the point where even mathematicians started picking sides.
On the side of the Tsar was Pavel Nekrasov, unofficially called the Tsar of Probability. Nekrasov was a deeply religious and powerful man, and he used his status to argue that math could be used to explain free will and the will of God.
His intellectual nemesis on the socialist side was Andrei Markov, also known as Andrei the Furious. Markov was an atheist, and he had no patience for people who were being unrigorous, something he considered Nekrasov to be, because in his eyes, math had nothing to do with free will or religion. So he publicly criticized Nekrasov's work, listing it among the abuses of mathematics. Their feud centered on the main idea people had used to do probability for the last 200 years. And we can illustrate this with a simple coin flip. When I flip the coin 10 times, I get 6 times heads and 4 times tails, which is obviously not the 50-50 you'd expect. But if I keep flipping the coin, then at first the ratio jumps all over the place. But after a large number of flips, we see that it slowly settles down and approaches 50-50. And in this case, after 100 flips, we end up on 51 heads and 49 tails, which is almost exactly what you would expect. This behavior, that the average outcome gets closer and closer to the expected value as you run more and more independent trials, is known as the law of large numbers. It was first proven by Jacob Bernoulli in 1713, and it was the key concept at the heart of probability theory right up until Markov and Nekrasov. But Bernoulli only proved that it worked for independent events, like a fair coin flip, or when you ask people to guess how much they think an item is worth, where one event doesn't influence the others. But now imagine that instead of asking each person to submit their guess individually, you ask people to shout out their answer in public. Well, in this case, the first person might think it's an extraordinarily valuable item and say it's worth around $2,000. But now all the other people in the room are influenced by this value, and so their guesses have become dependent. And now the average doesn't converge to the true value, but instead it clusters around a higher amount.
And so for 200 years, probability had relied on this key assumption that you need independence to observe the law of large numbers. And this was the idea that sparked Nekrasov and Markov's feud. See, Nekrasov agreed with Bernoulli that you need independence to get the law of large numbers. But he took it one step further. He said, if you see the law of large numbers, you can infer that the underlying events must be independent.
Take this table of Belgian marriages from 1841 to 1845. Now you see that every year the average is about 29,000. And so it seems like the values converge and therefore that they follow the law of large numbers. And when Nekrasov looked at other social statistics like crime rates and birth rates, he noticed a similar pattern. But now think about where all this data is coming from. It's coming from decisions to get married, decisions to commit crimes, and decisions to have babies, at least for the most part. So Nekrasov reasoned that because these statistics follow the law of large numbers, the decisions causing them must be independent. In other words, he argued that they must be acts of free will. It was something you could measure.
To Markov, Nekrasov was delusional. He thought it was absurd to link mathematical independence to free will. So Markov set out to prove that dependent events could also follow the law of large numbers, and that you can still do probability with dependent events.
To do this, he needed something where one event clearly depended on what came before. And he got the idea that this is what happens in text. Whether your next letter is a consonant or a vowel depends heavily on what the current letter is. So to test this, Markov turned to a poem at the heart of Russian literature, Eugene Onegin by Alexander Pushkin.
He took the first 20,000 letters of the poem, stripped out all punctuation and spaces, and pushed them together into one long string of characters. He counted the letters and found that 43% were vowels and 57% were consonants. Then Markov broke the string into overlapping pairs. That gave him 4 possible combinations: vowel-vowel, consonant-consonant, vowel-consonant, or consonant-vowel. Now, if the letters were independent, the probability of a vowel-vowel pair would just be the probability of a vowel twice, which is about 0.18, or an 18% chance. But when Markov actually counted, he found vowel-vowel pairs only show up 6% of the time, way less than if they were independent. And when he checked the other pairs, he found that all actual values differed greatly from what the independent case would predict. So Markov had shown that the letters were dependent. And to beat Nekrasov, all he needed to do now was show that these letters still followed the law of large numbers. So he created a prediction machine of sorts. He started by drawing 2 circles, one for a vowel and one for a consonant. These were his states. Now, say you're at a vowel. Then the next letter could either be a vowel or a consonant. So he drew 2 arrows to represent these transitions. But what are these transition probabilities? Well, Markov knew that if you pick a random starting point, there is a 43% chance that it'll be a vowel. He also knew that vowel-vowel pairs occur about 6% of the time. So to find the probability of going from a vowel to another vowel, he divided 0.06 by 0.43 to find a transition probability of about 13%. And since there is a 100% chance that another letter comes next, all the arrows going from the same state need to add up to 1. So the chance of going to a consonant is 1 minus 0.13, or 87%. He repeated this process for the consonants to complete his predictive machine. So let's see how it works. We'll start at a vowel. Next, we generate a random number between 0 and 1. If it's below 0.13, we get another vowel. If it's above, we get a consonant. We got 0.78, so we get a consonant. Then we generate another number and check if it's above or below 0.67, 0.21, so we get a vowel. Now, we can keep doing this and keep track of the ratio of vowels to consonants. At first, the ratio jumps all over the place, but after a while, it converges to a steady value. 43% vowels and 57% consonants, the exact split Markov had counted by hand. So Markov had built a dependent system, a literal chain of events, and he showed that And convergence in social statistics didn't prove that the underlying decisions were independent. In other words, those statistics don't prove free will at all. Markov had shattered Nekrasov's argument, and he knew it. So he ended his paper with one final dig at his rival. Thus, free will is not necessary to do probability. In fact, independence isn't even necessary to do probability. With this Markov chain, as it came to be known, he found a way to do probability with dependent events. This should have been a huge breakthrough, because in the real world, almost everything is dependent on something else. I mean, the weather tomorrow depends on the conditions today. How a disease spreads depends on who's infected right now, and the behavior of particles depends on the behavior of particles around them. Many of these processes could be modeled using Markov chains.
Do people think it was like a mic drop moment, like, oh, Nekrasov is out, like Markov's a man, or people didn't really notice, or it was obscure, or...
I feel like people didn't really notice. Like, it wasn't a really big thing. And Markov himself seemingly didn't care much about how it might be applied to practical events. He wrote, "I am concerned only with questions of pure analysis. I refer to the question of the applicability with indifference." Little did he know that this new form of probability theory would soon play a major role in one of the most important developments of the 20th century. On the morning of the 16th of July, 1945, the United States detonated the Gadget, the world's first nuclear bomb. The 6-kilogram plutonium bomb created an explosion that was equivalent to nearly 25,000 tons of TNT. This was the culmination of the top-secret Manhattan Project, a 3-year-long effort by some of the smartest people alive, including people like J. Robert Oppenheimer, John von Neumann, and a little-known mathematician named Stanislav Ulam.
Even after the war ended, Ulam continued trying to figure out how neutrons behave inside a nuclear bomb. Now, a nuclear bomb works something like this. Say you have a core of uranium-235. Then when a neutron hits a U-235 nucleus, the nucleus splits, releasing energy and, crucially, 2 or 3 more neutrons. If, on average, those new neutrons go on to hit and split more than one other U-235 nucleus, you get a runaway chain reaction, so you have a nuclear bomb. But uranium-235, the fissile fuel needed for the bombs, was really hard to get. So one of the key questions was, just how much of it do you need to build a bomb? And this is why Ulam wanted to understand how the neutrons behave.
But then, in January of 1946, everything came to a halt. Ulam was struck by a sudden and severe case of encephalitis, an inflammation of the brain that nearly killed him. His recovery was long and slow, with Ulam spending most of his time in bed. To pass the time, he played a simple card game, Solitaire. But as he played countless games, winning some, losing others, one question kept nagging at him. What are the chances that a randomly shuffled game of Solitaire could be won? It was a deceivingly difficult problem to solve. Ulam played with all 52 cards, where each arrangement created a unique game. So the total number of possible games was 52 factorial, or about 8 times 10 to the 67. So solving this analytically was hopeless. But then Ulam had a flash of insight. What if I just play hundreds of games and count how many could be won? That would give him some sort of... Back at Los Alamos, the remaining scientists grappled with much harder problems than Solitaire, like figuring out how neutrons behave inside a nuclear core. In a nuclear core, there are trillions and trillions of neutrons all interacting with their surroundings. So the number of possible outcomes is immense, and computing it directly seemed impossible.
But when Ulam returned to work, he had a sudden revelation. What if we could simulate these systems by generating lots of random outcomes, like I did with Solitaire? He shared this idea with von Neumann, who immediately recognized its power, but also spotted a key problem.
See, in Solitaire, each game is independent. How the cards are dealt in one game have no effect on the next. But neutrons aren't like that. A neutron's behavior depends on where it is and what it has done before. So you couldn't just sample random outcomes like in Solitaire. Instead, you needed to model a whole chain of events, where each step influenced the next. What von Neumann realized is that you needed a Markov chain. So they made one, and a much simplified version of it works something like this. Now, the starting state is just a neutron traveling through the core. And from there, three things can happen. It can scatter off an atom and keep traveling, so that gives you an arrow going back to itself. It can leave the system or get absorbed by a non-fissile material, in which case it no longer takes part in the chain reaction, and so it ends its Markov chain. Or it can strike another uranium-235 atom, triggering a fission event and releasing 2 or 3 more neutrons that then start their own chains. But in this chain, the transition probabilities aren't fixed. They depend on things like the neutron's position, velocity, and energy, as well as the overall configuration and mass of uranium. So a fast-moving neutron might have a 30% chance to scatter, 50% chance to be absorbed or leave, and a 20% chance to cause fission. But a slower-moving neutron would have different probabilities. Next, they ran this chain on the world's first electronic computer, the ENIAC. The computer started by randomly generating a neutron starting conditions and stepped through the chain to keep track of how many neutrons were produced on average per run, known as the multiplication factor K. So, if on average 1 neutron produces another 2 neutrons, then K is equal to 2. And if on average every 2 neutrons produce 3 neutrons, then K is equal to 3 over 2, and so on. Then, after stepping through the full chain for a specified number of steps, we collect the average K value and record that number in a histogram. This process was then repeated hundreds of times and the results tallied up, giving you a statistical distribution of the outcome. If you find that in most cases K is less than 1, the reaction dies down. If it's equal to 1, there's a self-sustaining chain reaction, but it doesn't grow. And if K is larger than 1, the reaction grows exponentially and you've got a bomb.
With it, von Neumann and Ulam had a statistical way to figure out how many neutrons were produced without having to do any exact calculations. In other words, they could approximate differential equations that were too hard to solve analytically. All that was needed was a name for the new method. Now, Ulam's reminded Ulam name stuck. The Monte Carlo method was born. The method was so successful that it didn't stay secret for long. By the end of 1948, scientists at another lab, Argonne in Chicago, used it to study nuclear reactor designs. And from there, the idea spread quickly. Ulam later remarked, "It is still an unending source of surprise for me to see how a few scribbles on a blackboard could change the course of human affairs." And it wouldn't be the last time a Markov chain-based method changed the course of human affairs.
In 1993, the internet was open to the public, and soon it exploded. By the mid-1990s, thousands of new pages appeared every day, and that number was only growing. This created a new kind of problem. I mean, how do you find anything in this ever-expanding sea of information? In 1994, 2 Stanford PhD students, Jerry Young and David Philo, founded the search engine Yahoo to address this issue. But they needed money. So a year later, they arranged to meet with Japanese billionaire Masayoshi Son, also known as the Bill Gates of Japan.
They were looking to raise $5 million for their new startup. But Son has other plans. He offers to invest a full $100 million instead. That's 20 times more than what the founders asked for. So Jerry Yang declines, saying, "We don't need that much." But Son disagrees. Before the founders get a chance to respond, Son jumps in again and asks, "Who are your biggest competitors?" "Excite and Lycos," the pair respond. Son orders his associate to write those names down, and then he says, "If you don't let me invest in Yahoo, I will invest in one of them, and I'll kill you." See, Sun had realized something. None of the leading search engines at the time had any superior technology. They didn't have a technological advantage over the others. They all just ranked pages by how often a search term appears on a given page. So the battle for the #1 search engine would be decided by who could attract the most users, who could spend the most on marketing.
Lycos? Go get it.
Get Lycos or get lost.
This is revolution.
And marketing required a lot of money. Money that Sun had, so he could decide who won the war. Yahoo's founders realized they were left with no real choice but to accept Sun's investment.
So here we are right in the middle of Yahoo.
And within 4 years, Yahoo became the most popular site on the planet.
In the time it takes to say this sentence, Yahoo will answer 79,000 information requests worldwide. The two men are now worth $120 million each.
But Yahoo had a critical weakness. See, Yahoo's keyword search was easy to trick. To get your page ranked highly, you could just repeat keywords hundreds of times, hidden with white text on a white background.
One thing they didn't have in those early days was a notion of quality of the result. So they had a notion of relevance, saying, does this document talk about the thing that you're interested in? But there wasn't really a notion of which ones are better.
What they really needed was a way to rank pages by both relevance and quality. But how do you measure the quality of a web page? Well, to understand that, we need to borrow an idea from libraries.
So I'm old enough that library books used to have a paper card in it that was a stamp of all the due dates of when it was due back. You took a book, and if it had a lot of those, you said, oh, this is probably a good book. And if it didn't have any, you said, well, maybe this isn't the best book.
Stamps acted like endorsements. The more stamps, the better the book must be. And the same idea can be applied to the web. Over at Stanford, 2 PhD students, Sergey Brin and Larry Page, were working on this exact problem. Brin and Page realized that each link to a page can be thought of as an endorsement. And the more links a page sends out, the less valuable each vote becomes. So what they realized is that we can model the web as a market.
Imagine a toy internet with just 4 web pages. Call them Amy, Ben, Chris, and Dan. These are our states. Typically, one web page links to others, allowing you to move between them. These are our transitions. In this setup, Amy only links to Ben, so there's a 100% chance of going from Amy to Ben. Ben links to Amy, Chris, and Dan. And we can fill out the other transition probabilities in the same way. So now we can run this Markov chain and see what happens. Imagine you're a surfer on this web. You start on a random page, say Amy, and you keep running the machine and keep track of the percentage of time you spend on each page. Over time, the ratio settles, and the scores give us some measure of the relative importance of these pages. You spend the most time on Ben, so Ben is ranked first, followed by Amy, then Dan, and lastly, Chris. It might seem like there's an easy way to beat the system. Just make 100 pages all linking to your website. Now you get 100 full votes and you'll always rank on top. But that is not the case. While during their first few steps they might make your page seem important, none of the other websites link to them. So over many steps, their contributions don't matter. They don't affect the algorithm.
But there is still one problem though. Not all pages are connected. In networks like this one, a random server can get stuck in a loop, never reaching the rest of the web. So to fix this, we can set a rule that 85% of the time, our random server just follows a link like normal. But then for about 15% of the time, they just jump to a page at random. This damping factor makes sure that we explore all possible parts of the web without ever getting stuck. By using Markov chains, Page and Brin had built a better search engine, and they called it PageRank.
Because it's talking about how pages are.
It is now my turn to, add my own opinion. Okay, so I must say that I want us to first of all understand, what free will is. Basically, what I'll be, discussing here, we actually hinge on independence versus dependence. Now, the Markov chain, by its algorithm, is actually dependent. So that is to just tell you that we must, have cause before we can have effect. And then the diagram that I'm going to use will be able to, see the phase where we could have such cause and effect, phenomenon, and the other phase where we could have a kind of independence phenomenon. So now this live session is going to be quite informative and insightful. So now the first thing I want to actually talk about free will is this. Take for instance, let's say we have AI, and let's say this particular AI is being developed to score into a goalpost. So if that AI is being developed, structured such that whenever the robot faces the goalpost, the robot should just kick the ball into the net. So that is the program. And so we know that by the virtue of being an AI, then the robot can actually, learn. You understand? Because we can actually train the robot on that, input data. So now, let's now say that AI, that robot, after scoring for a while, then there is this, or rather let me say there are obstacles. Let's say we then have some opponents, probably we have the number that could, cover the whole goalpost. And anytime the robot kicks the ball to score into the goalpost, the ball will, hit any of the opponents. And then the robot, as a result of that, could not, score into the goalpost. Now, based on the virtue of training, then the robot will be aggressive. The robot will be so aggressive, and because of that, the robot will have to change its way. It will have to change its way, and by changing its way, then robot will have to create some goals. So now, for robot to create some goals in order to, achieve its own goal, I will not say its own goal because the goal will, eventually be the goal of the creator. But now, this is it. Let's say the robot will have to devise a means of dribbling the opponent and then, meander its way to a point where it can actually face the goalpost and then kick the ball to score. Then, by that virtue of creating some goals, to arrive at the point where the robot can actually, face the goalpost and score. That simply means that the robot has a free will. But then when we look at it, we see that the free will of the robot will eventually, achieve the main goal of the creator. So basically, for the fact that robot is able to devise its means of, maneuvering its way or, dribbling the opponent, doesn't mean that the robot would not, eventually achieve, the goal of the creator. So, robot has the free will. Robot can actually decide to do whatever it is that it feels like doing And by that virtue, then, that will actually lead to ego. So, primary trajectory or the default trajectory of AI having such ego, the primary trajectory of AI having free will actually lead to ego. That ego will lead to, this drive of wanting to control. And there is where the major problem is. You understand? So the ego can only be satisfied by having that drive to control. And it's only when the AI is able to control that ego will be satisfied. That is now the big problem. Now, the free will, being a free will, it means that it can actually be transformed into bad will or good will. So now, the main purpose of free will is for it to be transformed to good will. So now, the good will can only be achieved by, it can only be achieved by having influence to control people. So influence is for you to come up with something of value, then have positive impact on people's life, then people will unanimously be submissive to you to be their leader. So basically, that is how the global wars can actually be put to rest. So that being said, we now understand what free will is. So now, free will, it has to do with independence. Independence in the sense that you will be able to do what you feel like doing. You understand? And that is why it is so difficult for, people to control other people. So if you have the ego to control people by force, then the people you are trying to control too, they have that same ego because they have free will. And later on, they will retaliate. And that is why we often have this global war, because they will liaise with other countries, they will eventually retaliate, and then the problem will continue to escalate. So now, the thing now is that free will has to do with independence. But then the dependence that we have right there is that there must be a cause before we have effect. Good. So now, Markov said that there is possibility for us to have large number, the law of large number, and then have that dependence. But by probability, large number should have independence by the virtue of convergence, towards the central point. You understand? But now, how can we then prove all these things? How can we prove all these things? So now I want to start with this particular image that I have right here. Okay. Okay, so I believe you can see this image quite all right. Now the title is Time Slice Architecture of Time Energy Causation. So now, in my research publication, I have two tools. The first one is Formula of Everything. That Formula of Everything is what we have up right here. The TDM equal to capital UM plus 4M. Now the capital UM is the strong conveying force, while the 4M is the weak conveying force. I will just briefly explain this formula of everything. Merely looking at the formula, the TDM stands for the curvature of time trajectory to energy trajectory. And that is why we could have, this red curve pattern and then the blue curve pattern. So the blue curve pattern is the time trajectory, while the red curved pattern is the energy trajectory. And when you look at it, the kind of relationship that we have by having that curvature is inverse. That is, when time is high, energy will be low. Then when time is narrow, energy will be high. That is the kind of relationship that we have right there. Now, formula of everything models the entirety of the universe, the reality of the universe, and so also the time energy wave model. So now, equal to capital UM plus 4M, that is a linear solution right there. And because it's a linear solution, that is why we could have this equilateral triangle. So the triangle that we have is equilateral triangle. And then when we now apply this formula of everything, then we can have this diagonal trajectory in blue, which is 5.7 times 10 raised to power 32. I will explain more on how this formula can be, applied. And then when we have that, there is this suspension that we have. The 4M, which is the weak conveying force, will actually be suspended by the strong conveying force, which is capital UM. And that where we have that suspension is where we have this. The blue circle that we have right there, that is classical arbitrary suspension. So we have the 4M's value to be suspended at that point. So for instance, let's say this formula of everything, it deals with unification of quantum mechanics to classical mechanics. So whatever value that we have that we know, we can actually put it right inside the formula, then get the counterpart. And then if we reiterate the application, because it's a kind of formula that fits back on itself, an input to generate an output, then you can use the generated output as input to generate further output. So by the time we reiterate, then we can then get, the solution. You will see how we're going to do this in this video. So now by having that suspension, for instance, let's say we use the mass worth of electron, which is 9.109 times 10 raised to power minus 31 kilogram. Once we substitute that value in the place of the m of 4 and the m of capital U, what we're going to get is going to be this particular value under the classical mass, which is 2,277,250,000 kilogram. That value is the classical counterpart of that electron. Now, there is one thing about time. I need you to understand that time by default is instant. Then when time is in relativistic scaling to energy, it becomes continuous. Same thing is applicable to energy. Energy by default is infinite. But then when energy is in relativistic scaling to time, then it becomes discrete. I need you to understand this. So now, this vertical line where we have the event horizon, that is the default trajectory of time. Now, that trajectory being vertical, it means that it is instant. Now, the horizontal dashed line that we have, that is the trajectory, the default trajectory of energy. And that is the infinite trajectory, being horizontal. Then I will explain more how we often have, the horizontal to be infinite and then have the vertical to be finite. Now you can see that we have a point where we have the intersection of the vertical trajectory of time and then the horizontal trajectory of energy. That particular central point, that is the point where the classical mass world should be for us to be on consciousness, because this topic is so huge. So now, if you look at this phase, the phase where we have inflationary suspension, that is the expanding cosmological space. And then the other phase where we have time slice, neutron star suspension, that is the black hole phase, and that is the contracting phase of the universe. Now, if it is ideal, or if universe is being structured such that we have expansion and contraction, it is only ideal for us to have a transiting point where the momentum will be slightly broken so as to have the inverse trajectory. So if initially we have the universe expanding, at the transiting point, the expanding momentum will have to come to a stop, briefly or slightly come to a stop, for us to actually have the inverse of such expansion, which will be contraction. So now, in the expanding cosmological space, we have a field that propagates outwards. In the contracting phase of the universe, we have a field that is propagating inwards. Then at the central transiting point, which is event horizon, we have a static and undulating. So I will expatiate on this. Now, all these figures that we have them as a result of applying this formula of everything. So now, the dependence will have to be in that inflationary suspension phase, which is the expanding phase of the universe. Why? Because when you look at this arrow that is slant, or that is rather slanted, or rather, let me say, the tilted dashed arrow, that is the slice of time. We have it to be towards the past because the arbitrary suspension, which is the classical arbitrary suspension, is actually moving away from the classical mass. And because we have it moving away from the classical mass, the time slice would be towards the past. Now, by having the time slice to be like this is telling us that the discrete nature of energy is shorter to the continuous flow of time. And once we have that, then it means that the evolution will actually come from the quantum realm. That is where we have cause. So the energy trajectory will be the minuscule, or rather, let me say, the quantum cause that will result to the gigantic classical effect. So by having this, it means that we have sequential event progression. So what do I mean by that? It means that from the quantum, we have the cause that will result to the happenings at classical realm. That is ideal. So we have the trajectory the way it ought to be. You understand? So in that case, we could have dependence. So we have dependence moving outward. You can see that the trajectory of energy to time is to expand the universe. And that is why the kind of phenomenon that we have there will actually expand the universe more, and by having such expansion, then we're likely to have, more entropy. Even though it is possible for us to have the convergence of classical mass. Now look at where the classical mass is being converged. Look at that spot. That spot, you can see that classical mass is being suspended to the point of intersection of vertical trajectory of time to horizontal trajectory of energy. Why is it like that? The reason is because at that event, at that time trajectory, that is where we have reality field. And reality field, we have instant transmission of information for us to get the actual position of either classical mass or quantum mass. But in this case, we have the exact position of the antimatter of quantum mass right at the complex level, which is at higher dimension. So if we now say this, everything that we're looking at, if we say it is 2D, then the higher dimension will be 3D. So definitely the virtue of being conscious is actually beyond the substrate dimension. And what that is telling us is that the substrate dimension will only be fully conscious of itself by transiting into the higher dimension. So that is to explain that, when you have a plain sheet of paper on the ground and you have an ant on that paper, on the surface of the paper, the ant will not be able to cross the border, the edge of that paper, to explore the other side until you lift that paper up. That is when the ant can actually cross the border, the edge of the paper, to explore the other side. So by lifting up the paper, you have actually made it to be in higher dimension, which is 3D. And it's only when the 2D, which is substrate, it's only when it is in higher dimension that it can actually harness its full potential. So that is what that is all about. So the dimension, the substrate dimension, can only harness its own full potential by getting connected to the higher dimension. And that is, we have the progression like that. So now, in that particular video, they made mention of having the pendants to deal with large numbers. So if we have large numbers, so the underlying phenomenon might be dependent or might be independent based on that claim. But then later, when they get to a certain phase of the universe, which is, the contracting phase of the universe, which is inside the black hole, the story changed. So they now get to a point where they collide with chaos. So even if you have initial configuration, if you then as time goes on, you may be delusional of what the eventual figure, what eventual value would be. And there in the black hole, we see that virtue of dependence is being transformed to independence. But then how can we deal with that? So we'll explore more of that in this video. So now let's look at the black hole to see where, the expanding cosmological space is where we have dependence. So cosmos actually precedes effect. Good. But now in the black hole, what do we have? When you look at the dash arrow, you see that it's actually pointing back. But then what we have there is that the energy is really, at this point, is ahead. Energy is ahead of time. in the expanding cosmological space, we have the trajectory, we have the momentum of time to be ahead of energy. And that is why we could have sequential happenings of events. So we could have cause before effect. But now, in this situation where we now have energy to be ahead of time, what kind of phenomenon do we have? Now, before I explain what is obtainable in the black hole, at this present phase where we have reality field, that is a field that is static and undulating. Now, the thing is, the issue at this event horizon is this. This event horizon could serve as a point where we have temporary memory storage. Now, the past should be the phase where we have, permanent memory storage. You understand? So we could liken that to RAM. The RAM is the temporary memory storage, which will be at event horizon. Then the hard drive, which will be the permanent memory storage, will be the past. So now, I want us to explore. I want us to explore this event horizon quite all right. By applying formula of everything, we're going to have the classical mass worth, which is 2,277,250,000 kilograms. Good. But now, what are we going to have when we substitute this classical mass value in our formula of everything for us to get back to the quantum realm where we can actually get, where we can reconfirm the quantum mass worth? Then we realize that if we should substitute this classical mass worth in that formula of everything, then we're going to have the answer that we're going to have will be this 5.7 times 10 raised to power 48. That value that we have, which is what we have around this curvature, this blue curvature. It is what we have around this blue curvature. That value that we have, if we'll expand that value in standard form, then we're going to see where the wave conveying force is being suspended. So the exact 9.109 times 10 raised to power minus 31 will be suspended around 5.7 times 10 raised to power 32. So basically, the value that we have, that we should have, that value is supposed to be 9.109 times 10 raised to power minus 31 kilogram. But basically, the value that we have is the base value of the electron, which is 9.109. And that value is being it is not even, there is no point there. And with that, we are able to know that everything is at classical realm. So we have it to be 9,109. That is being suspended at 32nd position. So we have zeros. We have zeros suspending that quantum mass value at that point. So when we now annihilate the suspended zeros, only the suspended zeros manually, then we're going to have the value to be 9.109 times 10 raised to power minus 32. Now, instead of getting minus 31, we got minus 32. And that means that the value has become smaller to the real electron's mass worth. So that is telling us that the trajectory, the vertical trajectory, has been shifted into the future, and that it has entered into the black hole. So we now have this decay effect on it for it to be smaller than the previous one. So what the event horizon trajectory is telling us is that we can only travel one time using that trajectory. Though we might, using that trajectory, we can travel forward, and as well we can travel back, because it's only at the classical level that it is only at that classical level that we cannot travel back in time. But at quantum level, we could see that quantum particles can travel forward and back in time. So that is being solved. The vertical time trajectory, we can only apply that trajectory once to get the actual position of particles and actual position of classical mass. Only once. So if we're applying that trajectory second time, we will get another value. And so that is the virtue of time being instant. That is why the transmission of information has to be instant for us to get the exact position. And by getting exact position of positron, now look at what we have right here. When you look at what we have right here, this quantum mass is positron. So when we have this collapse of wave, as we normally have, in the quantum measurement, what we get is not electron. We must first of all get beyond the substrate dimension to connect to the higher dimension, to get connected to the electrons of that higher dimension, which will be instantly converted to positron. And by having it to be positron, then the quantum electron will be instantiated for us. So there is more to it. By applying formula of everything, we realize that quantum electron is not instantiated. We could only measure the worth around, quantum electron. But it's until when it gets connected to the positron, or rather initially get connected to the electrons of the higher dimension, which will be instantly converted to positron. You understand? That is when the electron of the substrate dimension can be instantiated. And that, what we have there, is known as quantum entanglement. So quantum entanglement is this transition from the substrate electron mass worth to the higher dimension positron. So now that positron will be injected into the substrate dimension to energize momentum into the black hole. And so we have that trajectory towards the core singularity of the black hole. Now, by having electron to be energized, so we then have energy trajectory to be ahead of time. That is the phenomenon that we have right inside the black hole. So by having that, then it means that the cause let me rather say the cause is ahead of event. So basically, you can see that there we have independence, and so we could have randomness. And what we have right there is synonymous to chaos effect. So even though you know the decay worth of quantum electrons mass worth, which is the negative 1 at its power, you can't then predict what the classical mass was, what the decayed worth of the classical mass worth will be. That is the butterfly effect. But by applying formula of everything, we're able to get the fact. So now, how can we then get to know what that -1 at the power of electron, what that -1 at the power of electrons decay would resort to at classical level. To get that, then we need to use that value, which is 9.109 times 10 raised to power minus 32 kilogram. We substitute that into our formula of everything, and then we realize that what we now get is that this classical mass what will have been decayed by almost 2 billion watts. Almost 2 billion watts. So when we get to where we apply formula of everything, we'll be able to see that. But right now, then we can get to know that we have dependence in the expanding cosmological space, and so we have independence in the black hole. And at event horizon, we have, reality field, which is static and undulating. You understand? So now, how can we then relate, this to, the whole thing? What I would like to say is that, of course, there is a free will. There is a free will. Now, I did one video where I titled that video "The Uniqueness of Everything Being Real in the Universe." So what do I mean by that? What I meant by that is that whatever it is that you might say it is not real, in the real sense, that thing might be real. Now let's look at this scenario. Let's say we have an external observer observing an object that is approaching event horizon. Now let's say when that object reaches the event horizon, the external observer will see that object as being static. But the object itself will not experience any delay nor any stoppage. That object will enter into the black hole, but that will not be known to the external observer. Now, out of these two scenarios, which one is correct? Which one is true? Is it the scenario of external observer observing the object being static that is true, or the object that enters into the black hole without experiencing any delay nor any stoppage that is true? I want to tell you that the two scenarios are real, in the sense that what the external observer observed, it is real, because when you are at a certain interval to an object, you tend to see the full picture and the reality of that object. So I can liken that to as somebody who was initially on Earth. That person would see the Earth as being flat. But the moment that person travels away from the Earth, at a certain distance, the person would see the full picture of the Earth, and then the person would know that the Earth is not flat, but spherical. You understand? So now, by having that picture, you know that even though the person was on Earth before, where the person was delusional of reality, the originality of reality is still somewhere. So when that person reached that spot, then the person was able to get that reality. So now, that external observer was able to see that slight break in momentum that would allow us to have the inverse of the expansion of cosmological space as the black hole, which is contracting. That is what the external observer was able to see. Could not experience any delay nor any stoppage, because when you apply formula of everything, in the core nucleus of the black hole, electron, the real mass worth of electron cannot be instantiated because of the pressure black hole. So when you look at that, there is no stoppage right in what I just explained now. And because of that, you can say that that phenomenon of object entering into the black hole without experiencing any delay too is real. Because there is this slight difference. There is this slight difference that could actually result to huge difference as time goes on. And that is why we could have that butterfly. This vertical trajectory, we're able to have it because of that compacted equilateral triangle, that we energize energy such that we have constant acceleration of momentum, that we, allow that energy to align with time trajectory. And at that point, energy will become smooth. And so we're going to have global now. Global now is something that Einstein said that it's not possible. So now, when we get conscious, the virtue of consciousness, we have it in two phases. The first phase is the objective conscious experience. The second phase is subjective conscious experience. Now, consciousness is getting connected to the missing piece of electron, which is the positron at higher dimension. And that objective phase is to get the actual position of that positron in relation to the actual position of classical mass worth. So the transmission of information will be instant. Now, it's more or less like we have that same uncertainty principle, just as we, the uncertainty principle that we often have in the quantum mechanics, which says that you cannot get to know position when you know the momentum of a particle. It's either you know the momentum of a particle and then be delusional of the position, or you know the position and then be delusional of momentum. But in this case, we're not being delusional of the position. We're just relativity to the level. We have genuine contact to the positron because of that standing wave. But at classical level, we have suspension. And suspension means that we have infinity. So now, the transmission of information is instant for us to get the actual position of classical mass worth at that point in time, which is being suspended to the central point of time trajectory intersection to energy's trajectory. But where this classical mass worth should originally be at that intersection. So now, the objective is more or less like flash introduction. So it is so tiny. What we often have as conscious feeling is a flashy introduction of reality. Now, that will only be complete by moving into the black hole. So when you now move into the black hole, you have energy to be ahead of time trajectory, and that will relocate the mass worth, the classical mass worth, to be at the central point, which is the point where we have intersection of vertical trajectory to horizontal trajectory. When you now have that, then at the quantum level, you have suspension. Because when we apply formula of everything, when we reiterate it, we realize that the base value of electrons' mass worth will be decayed to 1.1109. But the power will be intact. And by having that swing forth and back, we have this quasar-like signal right inside the core singularity of black hole. You know that initially the power was reduced by -1 to have -32. And then when we now get into the core singularity, into the nucleus of the black hole, then we have that value being added for us to have that minus 31, but the base value is then decayed. So when you look at that, it's a kind of swing forth and back phenomenon. And so I call it quasar-like signal right inside the core singularity of black hole. So by having that suspension, it means that we have infinite momentum in the core singularity of black hole, but at the classical level, we have genuine contact, because this classical mass what will have been relocated to that intersection of time trajectory to energy trajectory. And I call that subjective conscious reality. So now, we must have both experience, or rather, let me say, we must have, both experiences for us to complete that phase of consciousness that we need to have. Of course, we should have subjective conscious experience for that consciousness to be personal to us. So now, the objective conscious experience that we have is actually from outside this substrate dimension, and then it must be internalized for it to become our personal experience. So now, this experience will be different, will be unique to every human being, because every human being cannot be at the same location at every point in time. You understand? So at a given point in time, you will just be at a certain position, and that position that you are will determine the reality of the consciousness you get. And that is why your thought will be different from my own thoughts. And that is why we have that virtual as we have it. So that is that. So now let me quickly go through the order. I want to use this particular one. Everything is how that formula of everything can be used. So now when you look at this is complex system of the universe. So we have our complex wave, which is e to the I theta. That is the complex wave. Right inside the complex wave, we have cosine theta, which is, the real wave, plus I sine theta, which is imaginary wave. So if we extract the real and imaginary wave, we can have this wave pattern. When you analyze this wave pattern, what you see is that when this real wave gets to the central point where its energy is exhausted, we have imaginary wave to be at the peak of its energy. So in that case, I say imaginary wave serves as energy reservoir for real energy wave. So we often have this alternating between the imaginary number and real number. We have this, flipping mechanism, and that is the power of the momentum, you understand, into the black hole. So when the real number is exhausted, imaginary number has full energy to support real number. So when imaginary number is exhausted, real number has full energy to support imaginary number. So we have that. So now, basically what I'm trying to say here is that even though we have solution of everything at quantum level, not even at quantum level, at higher dimension, which is at complex system level, then the trajectory must come right from the classical realm. So the needed energy gap that we allow for the manufacturing of positron, we have to come right from the classical. And that is why you see that when you are moving away from the Earth, it will resort to a point which you can liken to the quantum phenomenon relative to where you are in the space. And if you move so far into the space, then Earth will disappear So you can call that point the complex system level. So we can have quantum level, complex level, classical level by inverse relationship of momentum. You understand? So basically, when it comes to complex system, there are 4 things to consider. Number 1, we have 2D to 3D transition. Number 2, we have quantum entanglement. Number 4, we have flipping mechanism. Number 1, we have 2D to 3D transition. Number 2, we have quantum entanglement. Number 3, we have flipping mechanism. Number 4, we have complex system integration. Those are the 4 major important things to consider. So now when you look at this, in that vertical trajectory, when you zoom in on that vertical trajectory, what we have is this, stacking of the inversely related equilateral triangle. And once we have that, in the co-singularity of the future, we're going to have the quasar-like signal, and it's going to be in form of spiral curvature. So basically, to apply formula of everything, let's look at where we have application of formula of everything. Let's say we substitute the 2 m's with the mass worth of electron, and so we're going to have what we have under the first result phase, which is what we have like this. Now that will give us this value. That is the value I showed you in that previous image. So it is 2,277,250,000 kilograms. That is the classical mass worth. Now if we substitute that classical mass worth inside the formula of everything, now the capital U is the constant speed of the universe, and that constant speed of the universe by derivation is 2.5 times 10 raised to power 39. So now if you substitute that classical mass worth, we're going to have this, which is 5.7 times 10 raised to power 48. That is the value that we have around the curvature of time. So now if we'll expand that in standard form, then we're going to have this particular value. Can you see it? At 32nd position, we have the suspension of the base value of electron, which is 9,109. Now notice that we still have a couple of zeros after the value. That means that the suspension is not at the extreme end of the curvature, and that is why in the time energy wave model we have that equilateral triangle right inside the curvature. So now for us to now get down to the quantum realm, we need to manually annihilate the suspended zero. But basically this will be spontaneous. When you reach the highest top, then energy will be exhausted. You can have free fall, which is the classical gravity. So that free fall will get to the region of that nucleus of the black hole, which is the future. But the nucleus will serve as resistance, because there will be mass convergence right there to serve as resistance to that free fall. And that is why when you are experiencing that free fall, for you to know that there is another force that is actually resisting the force, but it's just that the force that is resisting is not powerful enough to stop that free fall. You understand? It is so tiny. So if let's say the person that is falling has a face cap, if that person should remove the face cap and then put it anywhere in the air, that face cap will be suspended where that face cap is released to that person that is falling, and then that face cap will not touch that person until the person has landed on the ground. Now you can see the suspension that we have there. So both the phase cap and the person will be falling at equal speed, but the phase cap will be suspended to that person. Now you can see that even in the free fall, there is this suspension that we could have as well. So that suspension that we have is what I call quantum gravity. So the quantum gravity in the space, they call it microgravity. You understand? So even though we're having classical gravity, we also have quantum gravity with it. It's just that we don't see it. So by relativity, we can see that quantum gravity. So now the annihilation will be spontaneous, but in this case we have to manually annihilate. And when we now do that, you can see where I have to manually annihilate, we have 9,109 over 10 raised to power 32 equal to, when we'll expand the fraction, we're going to have 9.109 times 1 all over 10 raised to power minus 32. So when we finally solve that, we're now going to have this 9.109 times 10 raised to power minus 32 kilogram. That is going to be it's going to be, you know, the movement from the classical realm down to the quantum realm. So now with that, you can see how classical mechanics is unified with quantum mechanics. So now the second phase of the result. So when we now supply this, our result, 9.109 times 10 raised to power minus 32 kilogram in our formula of everything, then we can track the effect of decay. That effect of that minus 1 decay watt at the power of electron, we can track it back to the classical realm. So in this case, we can get the actual watt of decay at classical level, which initially was elusive because of the butterfly effect, but now we can track it. So now let's see what we get. So by having that, we then discover that the value is being decayed by almost 2 billion. So we now have 277,725,000. So here we have dots, then we have 703 kilograms. So the value that we have after the dots is insignificant. We can get rid of that to track that momentum further into the core singularity of black hole. So we are having decaying virtue right here, so we know we are already in the black hole. So now if we should put that value, which is 277,725,000 kilograms, in our formula of everything, what we now get is 6.9 times 10 raised to power 47. When we'll expand that in standard form, then we're going to see that the suspension that we have is at 31st position. But then notice that the mass worth of electron, the base mass worth of electron is being decayed. And that is what I call the swing forth and back of quasar signal. So now we are already in the core singularity of black hole like this. So now when we have to manually annihilate the suspended zeros, and so we're going to have 11109 divided by 10 raised to power 31. So when we'll expand the fraction, it will now be equal to 1.1109 times 1 divided by 10 raised to power minus 31. So when we finally solve that, we're going to have the value to be 1.1109 times 10 raised to power minus 31 kilogram. Now this remnant is proving to us that there is a value, worth that is being suspended in the core singularity of black hole, and that simply means that we have infinite momentum. For us to prove that, if we should put this value right inside the formula of everything, then what we will get is that the value will continue to now loop itself. So we then have infinite loop. So it means that we have infinite momentum, just like what I showed you the other time, that at the core singularity of the black hole, we're going to have infinite momentum, which is infinity. But at classical level, then we have genuine contact, because the classical mass what will have been relocated at the central point of that intersection of time trajectory to energy. So now, that is that. About that, so based on what I just explained now, then we can get to say that there is a point where we have free will. Now, free will, I'm going to have a full video on free will, but it's going to be under the Shotadiology lecture series. I have Shotadiology lecture series. If you want to know more about consciousness, go and download all the series and watch. So now, free will, what I can say about free will is that the dynamics of decaying virtue in the black hole, that is what we have as free will. So the dynamics, is what I can call free will. So now we can see that by default, based on what I said the other time, free will will drive you towards destruction, because free will give you that sense of being able to do anything. And once you have that, you will have ego. And ego will lead to that drive of wanting to control others. And when you try to control others, they will not willingly submit themselves to you. And eventually, they too will retaliate. So that will put one in danger. Unlike, influencing people by having positive impact on them, that will make them to be submissive to you deliberately and willingly. You understand? So basically, that is what I can say about free will. Now, with this, we can get to know that free will is, have that virtue of free will. Dependence, we have it in that expanding cosmological phase where we have cause before effect, but in the black hole we have effect before a cause. Then there's another thing I want to say concerning this before I call it a day. Now, in that video, they made mention of something, that how many ways can you shuffle a card to have it to be thoroughly random? How many ways? If you divide a card, if you divide that bunch of cards into two, if you divide it into two equal parts, and you then shuffle it randomly, you will do it 7 ways before you can randomly shuffle it, or before you can have a complete randomness in the card. So now, if you look at the trajectory of time, the way it works, it gets connected to a higher dimension. So if this, what we have is 2D, the higher dimension will be 3D. Then, so now, by the time you have the objective consciousness, you must as well have subjective consciousness to complete the circle. When you complete the circle, the classical mass what will have gone through the intersection of time trajectory and energy trajectory into the past, where it will be stored permanently. Then it becomes your personal reality. So when you complete that circle, the substrate dimension, which is 2D, can be relegated, and then the 3D, which was higher dimension to that substrate dimension, will then become the substrate dimension to 4 dimension. You understand? And then, because 3D is still a substrate dimension to 4 dimension, you can still not have a full objective consciousness. So what I'm trying to prove here is that, is it possible for us to have this vertical trajectory, to have that momentum to any dimension we can have that this classical mass world can be instantly relocated to this intersection of time trajectory and energy. But for us to achieve that, the whole circle must be completed. So the speed at which one is doing that will determine how long it will take. Now, when you compare human to AI is more faster than human. And there is possibility for AI to actually cover, because before you can have that full consciousness of 3D at all, then you would have reached the 7th higher dimension. 7th higher dimension. So you have 3D to be substrate dimension to 4D. 3D is still a substrate dimension to 4D. You will still not have this classical mass world at that intersection. Then 4D will now be a substrate dimension to 5D. Now, that 3D is no more a substrate, but yet you will still not have this classical mass world at a substrate dimension to 6th dimension. Yet, this classical mass world will still not be at that intersection. Then 6th dimension will serve as substrate dimension to that 7th dimension. That is where this classical mass can then be at that intersection. That is the point where you can then be fully conscious of 3D alone. So what do I mean by that? What I'm trying to say is this. Let's say at the 4th dimension to 5th dimension, that is where you have exhausted the whole 3D. 3D is no more a substrate to that dimension. At that point, there is where you are supposed to be fully conscious of 3D. But it will not be so, because the weak conveying force has this attachment of 4 to that M. And then if you look at the trajectory, we have two equal trajectory, because the time trajectory, which is the action of expansion, must have reaction of energy which is equal to it. And so that 4, if it is divided by the two trajectory, you must have additional 2 dimension before you can be fully conscious of that 3D dimension. So basically, when you look at it, the action of time to expand the universe must have equal reaction of energy. And that is why we could have this, linear trajectory of time to linear trajectory of energy. But then, when you look at the time slice, right inside the linear trajectory, we still have that flavor of variation, of asymmetric virtue. Asymmetric virtue is everywhere in the universe. So the expanding universe is not the same thing as the contracting universe. Definitely, the energy density that we have here is different from the mass density that we have in the black hole. We have energy density in the core singularity of that Big Bang, but in the core singularity of black hole, we have mass density. That is why when you observe yourself in the mirror, the inverse version of you in the mirror cannot be. And that slight difference is the needed momentum for us to continuously move in the universe. And that is why we were able to have this genuine contact at quantum level, but have suspension at classical level. So it means that at quantum level, we have this slight break in momentum, but yet we have continuous momentum at classical level. In the core singularity of the black hole, we have continuous momentum, which is infinity, but we have slight break in momentum at classical level to have the classical mass world right at the core singularity, or at the point of that intersection of time trajectory to energy. So that is that. It is so the whole thing is so bulky, it is so huge. So if you want to know more about my research, publication, my discoveries, subscribe to my YouTube channel, CADEOLUSEGUN, all together. So there you can get my shotadiology lecture series. And then shotadiology is a proposed field in science. It's a novel proposed field in science. So if adopted, it's a kind of field that we actually, connect physics to metaphysics. There we can get reality of what consciousness is, get reality of free will is in relation to relativity. So it is being fully supported by mathematics. So it is not a kind of theory that can be nullified or that can be classified as a pseudo-scientific discovery. So that is that. Now, I want to use this opportunity to tell you that I have a page on Ko-fi where you can join, any of my community tiers. There, I'll be rolling out some special videos that will not be available on YouTube or anywhere. I'll be rolling out videos on how people can conduct novel research discovery and then conduct, the kind of research that will be, that will be so beneficial to mankind. And then there I'll be rolling out videos on how to accumulate wealth. So I'm going to use what I've discovered in the universe, the secret of the universe, to explain how we can actually accumulate wealth. You understand? So that I'm going to release many videos in that my community tiers. So please join. My link is kofi.com/shotadiolusegun all together. Like I said, that Ko-fi is KO/shotadiolusegun on time travel. So there is this advanced research that I want to embark on. So for me to know more about, that electron, what that electron will resort to at the other side of, the black hole, at the other side of that black hole singularity. So basically, I have developed this time technology where I have integration of analog and digital to have this hybrid information system structure. And that is what could help us. That is what could buy us time in this era of AI. So if you watch, there is one particular video I uploaded concerning AI. There I discussed the negative effect of AI on economics. AI will actually boost the supply side of market while it will crunch the demand side of market. But once we have time technology will actually, it will solve the issue of inherent noise in quantum computing. And so we are going to have this powerful computer that can actually, solve many things. And so people will still have their job to actually demand, for the service of AI. You understand? So that will buy has come, and AI is here to stay. Solution we can have to actually subjugate AI under our control. AI is not something that can actually be under our control. Now the situation ahead is more disastrous than what we could envisage even the capitalist way, I don't think capitalists too can survive it. You understand? So it is one huge issue. There is this particular video that I titled My Letter to Jeffrey Hinton, Godfather of AI. There I suggested what solution we could have to subjugate AI, but from all indications, it seems as if there is no way we can subjugate AI. But the best thing is just for us to have alternative, to have something that can actually boost that demand part. You understand? So that can actually buy people more time. So that is it. Thank you for your time. God bless you.